Hello, I'm Thomas Kugelstadt, Applications Manager of Texas Instruments Industrial Interface Group. Today I'd like to discuss a new solution on measuring high DC voltages with low-volt controllers. Older designs used resistive voltage dividers to attenuate a high input signal and make it accessible to low-volt isolators and subsequent microcontrollers. This approach is power-hungry, as the input current increases proportionally with rising input voltage. Also, the design suffers from high component count, which consumes enormous board space and doesn't allow for small form factor equipment design, particularly in modern digital input modules with multiple input channels. A new device called Digital Input Serializer, or DIS, reduces board space by more than 50% and power consumption by up to 80%. This device provides the signal conditioning including attenuation, current limiting, signal strength check and noise filtering for all 8 input channels IP0 to IP7. Afterward, an internal shift register converts the parallel inputs into serial output data. Simple interface control in the form of a load pulse and a serial clock enables a microcontroller to read the shift register content asynchronously, in this case via a digital isolator. Inside the DIS, each input channel is current limited and checked for signal strength and stamina. Current limiting is a key to substantial power savings and requires only one external resistor, namely Rlim, to set the current limit for all 8 input channels. The check for signal strength includes a current comparator that distinguishes between leakage and proper input current, and a voltage comparator that ensures the input voltage level is above 5.2 volts. If both comparators output high, a debounce filter delays the input signal by a user-defined debounce time. If the input signal outlasts the debounce time, it is accepted as a valid input status, and the filter output changes in accordance with the input polarity. The filter output state is now ready to be latched into the shift register via load pulse from the controller. In the case of a high output, the filter switches the current limiter output from ground to the RE pin. Input current entering at IP now exits at RE, and the LED turns on, indicating the presence of an input signal. In the absence of an input signal, the comparator and filter outputs are logic low, and the current limiter output is switched to ground, thus keeping the LED turned off. Configuring the device requires 3 simple steps. First, calculate Rlim for a designed current limit using equation 1. Second, determine the input resistor values for a desired input on threshold via equation 2. Third, connect the debounce select inputs dB0 and dB1 according to the debounce table. Due to the simple structure of the serial interface, cascading or daisy chaining multiple devices is easily accomplished by connecting the load and clock lines in parallel to all serializers and connecting the serial output SOP of a leading device to the serial input SIP of a following device. The sub-output of the final serializer in the chain connects to the isolator or microcontroller I/O. Texas Instruments offers an entire family of digital input serializers with various features, including supply voltage monitoring, thermal protection, parity bit generation, and a single 5-volt supply. For more information, such as datasheets, user guides, and evaluation modules, please visit our website on www.ti.com, HVS88X. Having shown you an elegant, power and space-saving approach to measuring high voltages with low-volt controllers, I'd like to thank you for your time watching this video.